All right, it's pretty early, so I'm going to potentially just do a lot of this review for the cumulative because you should roughly be able to recall what's happening and everything that's here. It kicks back with Unit 1, talking domain, talking range, talking inverses, finding inverses respectively. If it's the table, that's light work. You already have the table that's here, so just switch X and Y respectively. So instead of -2, 9, we get 9, -2. Instead of -1, 5, 0. You get the idea. You see somewhere it's an equation, so I'll give you a game plan. You want to switch X and Y. And solve respectively. So you should look at this and say, oh, it's f of x equals this. And maybe you say initially that's just y equals -2/9 x. But if you switch them, you would have x equals -2/9 y. And to solve for this y, you want to multiply by your reciprocal, which for the fraction should be -9/2. So that on both sides. 2's and 9's cancel. So you're now left with -9/2 x equals y. You have a graph where I would look at this and say that, yeah, you could get the equation of it, or you could just mirror some of these points. Because if you look closely, there are some points that are more convenient than others. So this -2, -3, you could rewrite that as -3, -2. You could also acknowledge this point here, -5, -5, which actually you could keep as is, as for the inverse, so you don't have to switch this one. So once you have 2 points, again, we have this one here at -3, -2, because we switched this one around. Just make the line. And I think that there's a progression here of like over 3 up 2, so do your best to make sure that that's seen. And this is done for up 2. This is You get the idea, though. It should be these points. Oh, yeah, duh. It's because I want to go through this point. My bad. We'll also just this. Yeah. There you go. Are you still watching? Did you enjoy that blooper? Yeah, sorry. So the slope is actually over 2 up 3. So over 2 up 3. Some other points of interest on here are this point, this point, this point. These make sense? Okay. I am going to give you a moment to get your hands dirty trying to get the inverse of this. Again, use the steps that are here, switch X and Y, and then solve for Y. I will have the answers here in a second. Maybe not so much the steps, but sit tight. Pause the video, try them out. So if you did this correctly, this is another linear line. 2/3 x minus 7 now turns into 3/2 times the sum of x plus 7. So that's your inverse. No need to limit the domain because it's just linear, so everything's going to work there. Whereas for here, that you're taking a square root over this x minus 3 divided by 2. So you might be curious how I get this domain. Well, I hope you can recall that the inside of this radical should be greater than or equal to 0. And if you solve that, you end up saying in so many words in an inequality that x is going to have to be greater than or equal to 3. The opposite of an exponential function is a log function. Luckily, it's base 10. And the domain for that's from 0 to infinity, parentheses. So there you go. Functions are there. Was that easy? Was that tough? You should be pretty good with this because you've seen it before. This is the cumulative. You did a problem like this probably on the first quiz that you took, there's 1 inch for this sprout, and it continues to grow half an inch per day, and you're finding the height based off of the given number of days. So you start with 1 on, you could think of this as like day 0, you start with 1, because it has to have some height, you know? And then every day, so every D, you add half an inch, and that should collectively equal your height. And then you have the brother that wants pretty much the inverse of solving for the height. So if you approach this with the steps that I've given you above, you could deduct 1 on both sides, and you should actually switch this. There's actually no need to switch this around because you're already solving for a different variable. So if you move the 1 over, you're left with 1/2 times the days equals minus 1, and then move towards getting a hold of variable D, multiply both sides by 2. You're now left with the number of D's equals the height minus 1, but then multiplying that all by 2. Why are these inverse functions? They get different variables. It's the same story, similar story, solving for different variables. You can get away with that. Can any even function be invertible? Like an even function where it's like a quadratic or an exponential function? Can any even function be invertible? You could debate this one. I'm gonna say yes, but you probably have to restrict your domain. And you can think about the example on the first page where we had that square root in the mix. You had to restrict that domain because if you really think about an even function, it's going to look like that. And then the inverse is going to be this almost belly shape. If you were to take everything. But let's imagine that we cut the quadratic in half. And then it would leave you with this. It's like it would leave you with a positive half, wouldn't it? It would leave you with one of the halves where, like, collectively you would end up, yeah, it would leave you with the top half, I'm pretty sure, because all of those coordinates are positives. So then, if you graph this is like, I don't know, x squared, and then this is just the positive version of square root of x. If you limited this domain so that it was just 0 to infinity, it could work because then the range on this would be 0 to infinity and there's no overlapping of the function, and it works because it can maintain a function type of setup. So that makes sense to me. Okay, you have log functions. Recall if you're given a log with base A, argument B, and it equals y, you're going to have to go to exponential form every now and every other problem, pretty much, where A kicks out, it uppercuts y, and then what do you think this is now equal to? Hopefully you're saying B. So you could say that this is, you guessed it, log form, and this is exponential form. So you have to do that quite a bit. So you should look at this and think that this all equals some number. And in exponential form, you're saying 36 equals 6 of some exponent. So I hope you don't have to guess and check too much on this. It should just be that it's equal to 2. And then a golden rule, if you have an argument of 1 in a log, it all has to equal 0. Because 6 to the 0 power is 1. What's the equation for this vertical asymptote? So I look at this and think that there is a horizontal shift going towards the right 4 units. So if the log function originally the OG lot function. If the lot function is something like this, I'm not being specific with points, but it would now move over to the right 4 units. So over once, twice, here. So you would now have what was originally this asymptote here has now moved over once, twice, 3 times, 4 times here, where x equals 4. So what's the equation of the vertical asymptote? X equals 4, based off of the inside, again, horizontal shift. So hopefully that makes sense. Use the graph and also what you know about properties of log straight equivalent equation. This is going to use the not multiplication property. Well, I mean, you get kind of clean up. But product property says that if you have log A times B, we can rewrite that as log of A plus log B. So you should look at this and say that it's really just log 2 of 32 plus log 2 of x. Log 2 of 32 is just 5. And then you just add on log 2 of x. And if you think about the graph, this would make sense because it really took log 2 of x and just shifted it up once, twice, 3 times, 4 times, 5 times. And if you're not convinced, you can try out the other points. They all match. Everything went up 5 units. And I guess while I'm here, I'll just show how the other points went up 5 units. Because what else? There's 4, 2. Here's 8, 3. And also 16 quattro. So 1, 2, 3, 4, 5. Makes sense? You have a quotient property, which says that if you have log of A over B, kind of similar to product property, but you can rewrite that as the difference of those logs respectively. So if you think about this log 2 of x, menos log 2 16, this is just 4 in disguise, and you're subtracting 4. So it would make sense that the graph respectively is log 2 of x just minus 4 units. So it goes here, down 1, 2, 3, 4. Goes here, down 1, 2, 3, 4. And I think you get there just one more point, not the next. 1, 4. Yeah, there you go. So again, vertical shifts down 4 units. Your game plan for this, you're going to isolate whatever is the exponential situation, and then probably go to log term or log format. So step 1, isolate the exponential function. Step 2, go to log form. Maybe take a moment to try these out and get your hands dirty. So hopefully you got something like this. I kind of lied in problem 4, saying that you had to go to log form, but once you divide by 5, you should hopefully see that they're the same base, and that you can set the exponents equal to each other, right in here, and then solve for x. X is 2. This is already in exponential form, with no like conflicting or annoying a term times this. So you can immediately go to log form. Recall, if it's not written as the base, you can assume it's base 10. And then deduct 1 and then divide the whole thing by 2. Simple, right? Part equation, this is a super simple plug and chug. I don't have a calculator on me. Well, actually I do. I don't really feel like knocking that out. I've done these problems before. So 10 years for T. You have 250 as your principal. Recall that this is 2%, so you really want your rate to be 0.02. A lot of people ask me if you use the other equation for this, but there's no need. You have bacteria that's growing on this banana peel. There's 20 bacteria now, and they grow continuously at 5% per hour. how long will it take for the population to double? So if it's 20 now and it doubles, you're really saying that you're aiming for 40, but you're starting with 20 with a rate of 5%, and you're solving for t. So do a little bit of work. You'll get 2 equals this 0.05t. And your inclination here might be to go to log form, which isn't, yeah, that's like pretty much what you're doing when you take a back as a base. But recall that log base a can be rewritten as just ln, natural log. And then keep going, don't stop till you're done. This is some number of hours. I think it's like 13 potentially. So I'll let your calculator do the work on that. Key thing here, show if it's the same as that. So what could you do? You could evaluate this as 3. You can rewrite this as log 5.5 plus log 5 of x. This is just 2. So you're really saying that 5 plus log 5 of x might be equal to this. But if you do a little bit of digging and rewrite this using product rule, you're going to claim that log 5 of 3 plus log 5 of x plus 2 is equal to this. But this is less than 1, and this is adding on 2. So you're saying that, like, approximately 2 and some fraction of a vertical shift is equivalent to 5, and that ain't it. So they're not equal. These don't equal each other. Again, I was saying this is like 2 and a fraction, because 5 to some power equals 3, and it's going to have to be a fraction. And that just doesn't work. Okay. I will tell you not to worry about this problem. Happy holidays, late holiday. Don't worry about that problem. You have these, and I'll pretty much give you a game plan. You're going to isolate e to some power. You're going to go to ln form, and then you're going to continue to solve for x if need be. Okay, this is luckily in e form. Throw it back as the base on the right, so ln of 5 equals 0.02t divided by 0.02, and whatever this is. Yeah, this is interesting. Your choice of logarithm basis should be obvious. I agree on that. Divide by 85. That's that. I'll start to speed run this because you should know what you're doing at this point. Equals ln of this fraction, which I wouldn't care about until the very end, because you can just let the calculator do the work. And AI is very helpful. I don't know if a calculator is considered AI, but you know what I mean. This is your answer. I'll let your calculator again do the work. Same song and dance here. I'm not even going to show the steps because I can just think it out in my mind. ln of 30 over 58 minus 1 divided by 4. That equals t. Okay, simple, right? Exponent work. I'm going to zoom in on these because I had a plethora of questions about these. How would I approach this? I would take your time with these exponents, bringing them in, multiplying them respectively to the exponents that are there. Getting that. Do the same here, or maybe you even pause for a moment and say that really this is 5 squared and this is base 5, so let me actually rewrite this as 5 squared, and then 2 times this -2 gets you an exponent of -4. Do the same for n and for a. And then how do you think that we can carry this along with these exponents? Let's add them up. So we get 5 to the negative 1 power n cubed times n to the negative 6, n to the negative 3rd power, a to the negative 12 power, exponent rule. If you have a to some negative number, you can rewrite that as 1 over a, but now to the positive number. Pretty chill rule. What you think? So rewrite all of this as a fraction, because I prefer to not have negative fractions in the final answer. It's just, it lacks taste. You know what I mean? There you go. 1 over that. Focus first on your coefficients. 4 times negative 2 is negative 8. M squared times m is m cubed. N to the 1/3 times n to the 2/3 is just n. And then r to the first times r to the negative 1 is just r to the 0, so there's nothing noteworthy there. Ooh, much longer on this. There's so much here. It's kind of crazy. You have a few approaches you could take here. Like, honestly, if you really think about it, you could say that this is, I'm just now seeing this in a different light. You could say that this is 2 minus this negative 2, because the whole inside's the same. So if you do 2 minus that negative 2, you're really saying that it's 2 to the a minus 1 all to the 4th power. And if you really think about this, 2 to the 4th is 16. A to the negative 4th power is like a over 4, a to the 4th, put in a denominator. So that's your final answer. I think that is the quickest way to solve it. If you look closely, worst case scenario, you distribute this 2 and start to subtract the bottom exponent, and you'll still get 16 over e to the 4th. Hope that makes sense. And what about here? Distribute this, both. Let's see here. I personally don't rewrite the negative exponents too much because I just see these problems and kind of know how to solve them. But I do try to rewrite to a common base when possible, because I think that's just a leg up on the game. And so you could approach this in a few ways. You could say that the top, you can add those, and this should actually be a 6th power. So this gets you x cubed over a 4 to the negative 1 power, still with x. You can then subtract this x from this, so this is now x squared. And dividing by negative exponents, fair game to just rewrite as the positive version in the top, multiplying with all that. So 4x squared is your final answer. I'd say that these are the definite throwbacks of this fraction work, but you're totally capable. Just take your time and know the rules. I don't know if that's the answer you want me to give, but that's what I would suggest. F of x is even, g of x is odd. Recall that if you have an even function, you have f negative x, like all the negative terms, be the same output if it was positive, whereas if it's odd, you're saying that f of negative x equals a negative function outcome. So, all right, well, this is saying that if it's even here, you're saying that whenever it's a negative input, the positive input's going to match the same outcome. So this is also 2, based off of this. And this negative 2's outcome should be the same as this positive 2's outcome. So this is also 2. This is 0. Okay? And so if you plug in negative x coordinates, hopefully it's equal to the negative version of positive input or negated. So this is saying that f of -2, and you can think this out. Like, don't be afraid to do this. This is saying that f of -2 should be equal to the negative version of f of 2. So if this is 2, and it should be equal to the negative version of f of 2, you could say that really -2 should be equal to f of 2. And you can also say that for it's -1. And 0 is just going to be 0. So you see some differences here in the 1, 2. You have this function, you're getting the inverse. Is it invertible? Yes, because it's cubic. And I'll just do a quick sketch of this. You should look at this and say you're going left 2, going down 4 units, and then flipping. So that, super quick sketch of this. The following. 1, 2, 3, 4, 5. There you go. So -2, -4 that's a good point for sure. Also -3, -3, and -1, -5. So that's C of x as a quick sketch. If you do your damage on this, getting the inverse of it, you would add 4, divide by -1, take a cubic root, and then lose 2. This is C inverse of x. Some quick points on this so that I don't clog the feed, which is really this graph. This had points of -2, -4, so that means that -4, -2 is a point. This also had -3, -3, so that actually stays. And then -1, -5. So -5, -1. These are for the inverse function. Makes sense? Okay. Degree 4 polynomial that has a double root at x equals 2. So this is saying that x minus 2 is going to be a factor. And its double root means multiplicity of 2. And also roots at x equals 1. So x minus 1 is going to be a factor. And also x plus 4. Recall that whenever you're going for the factored form, you need x minus your root to whatever multiplicity it's in. Okay. And so what's this end behavior saying? If x approaches infinity, function goes towards negative infinity. So right now, this is definitely a quartic function. It's going to behave like this. But if you really think about the end behavior, this is saying that at the tail end, it needs to dip. So this is saying that we need to make it a negative version, because that'll work, and that'll suffice. It'll be upside down parabola, opens downwards. So that's what I would push for. Quick sketch. A few things you should definitely be knowledgeable of. The roots and their respective multiplicities. The end behavior is going to be pivotal. And also your y-intercepts. Oh my gosh, I need water. You have a root at 2. Root at 1. Root at -4. And if you do a quick check of P of 0 to get your intercept, you end up with some work that looks like this, that, and then 4. So you're subtracting 4 times -1 times 4, so 16. Let me double check. So, can you do this right? This is good. This is good. Yes. -2 squared is 4, but this makes it negative. And then this is -1, and 4 is still along for the ride. So negative times a negative is positive. So there should be a y-intercept of 16. Positive 16. Let me know in the comments below if I'm right or wrong about that. And for the request, it's going to start low, actually. So what happens is p of x goes to negative infinity. Since this is an even root, we say that p of x is also going to approach negative infinity the same way that we set it up here. Think about what you did with quadratics way back in integrated 2, because that mentality should help you through this. So you're going through where x is -4. I don't know exactly how you get to the 16, but you hit it, and then you probably bounce down. You cut through where x is 1, bounce up, hit where x is 2, and then bounce down again. So again, this is where x is -4, this is where x is 1, and this is where x is 2. Probably something like that. Again, these are the things I'm looking for. Right y-intercept, good end behavior. The roots have their respective multiplicity. Again, recall this hits and bounces because of multiplicity of 2. So it behaves kind of like a quadratic. I'm going to do, probably just do 2 of these. Part D, I'm not going to worry about that one, so you can just drop it like it's hot. For the rest of these are quality problems. I'm looking at this and I'm thinking that one of the factors for this is going to have to be x plus 1 because it just cuts right through it. There's also a factor of x because when x is 0, it hits, so x minus 0 is just x. And then finally, x minus 1, but with multiplicity of 2 because it hits and bounces. And so you might get this and you think, oh, I'm done, I'm hot stuff. I don't care about the A term that's there, but you should, because that's a thing you should care about. You have this point. Oh, God. Sound like a pork rind. You have this point to solve for A, and if you put in the work and plug in where x is -1/2 and y is -27/16, you run all that work, which you should, you're roughly going to get -1/2 plus 1, which is just 1/2, times x, but now it's -1/2, times -1/2 minus 1, so -3/2. And remember, this is being squared. And you're saying that this all equals -27/16, right? Because that's what the point that they gave us is saying. You might be curious, why don't you just use the roots with y-coordinate 0? Well, that's not really going to help us solve for A because you need some substance on both sides. You can't just have 0 equals 0. So you run this arithmetic, simple fraction stuff. It's -1/2 times 1/2, so -1/4. And if we square this, 3 times 3 is 9. 2 squared is 4. We're still claiming that this equals -27/16. You take this further, you're claiming that A times -9/16 equals -27/16. So A is going to have to just be 3. If you're not convinced, just focus on up here. You're claiming that -9A equals -27, so A has to be 3. It's pivotal. Please go for the A term. Don't forget about it. What's that Simple Minds song? Don't you forget about me? Don't forget about A. Okay, cool. Good one. I like those problems a lot. I would look at this and say, what with it? We have a root of -2, so x plus 2, multiplicity of 1. You have x being squared because this hits and bounces. And you also have x minus 2. And I know that this bounces down. So look at this really closely. This behaves kind of like a negative a term for a parabola. So the a term here is probably going to be a negative. But we can test one of these points here or here to try and solve for it. So I'm going to do the positive versions because that makes my life a lot easier. So I'm checking when I plug in where x is 1, I have 3. 1 squared is just 1. 1 minus 2 is -1, and I'm claiming this should be equal to 1. If you run this arithmetic, you're going to claim that -3 times -a equals 1. I could have easily just left this as a positive a, but I'm extra and I saw the writings on the wall, and I used my judgment to say that it should be negative, but you'll even see here it doesn't really matter. I would have gotten this answer anyway, because I'm claiming that positive 3a equals 1, so a equals 1/3. So a is 1/3. So you have 1/3, parentheses, and ooh, no, there's no way. Don't tell me I made a mistake. Oh no, I didn't. Oh wait. No, I'm good. So a is 1/3, but it's it's subtracting it. So -1/3 is actually what it needs to be. So yeah, I'm standing by this. So this is your factored form. Or we're not asked to go to FOIL standard formula. No, there's possible formulas for it. Here you go. I think that making this a -a probably threw me for a loop, but I still recovered. Factor. I look at this and I think 4x is common with everything. If I factor out 4x, it leaves me 2x squared minus x minus 60. It's like minus 15. I'm not trying to do factors of 100 and 20. But I am trying to do factors of a times c, which is -30. That add up to -1. So -6 and 5 work just fine. So I can rewrite this as 2x squared minus 6x plus 5x, and then factor by grouping. If you look at the first two terms, factor out what's common. It's 2x squared, and then x minus 3. Factor out x minus 3 here. I think that's a really stellar move so that you're not looking at the final two terms and thinking, oh, what's the greatest common factor? Just know that if you did the first two right, the binomial should appear again. So just a little bit of housekeeping here, rewriting the 4x that was factored out at the beginning. And then now moving towards the final answer, the factored form with, sorry, this should just be 2x. 2x plus 5 is a factor, x minus 3 is a factor. Set these equal to 0 respectively and solve. Say that your roots are going to be 0, -5/2, and also 3. And I guess if you want to get real mathy with it, which I challenge you to do, you could also say that it's a set of this with these curly brackets and say that those are your roots. I don't know if this is actually technically the best way to describe it, but there you go. I'm using invertible. Yeah, you can isolate x in this. You can isolate x for sure. Whereas here, you're going to have a very challenging time trying to isolate this. You would probably look at this and say, you factor by grouping, which now I'm like slightly interested if you can. I don't even have to do this. I'm just curious what the factoring of it's like. Well, cool, you get a little difference squares. But there are a lot of x terms here, and that's why I would say probably can invert this. Whereas here you could, because you have x minus 2 in parentheses, it's kind of tucked away. And I'll even entertain it where you could say that the inverse is going to be subtracting 4, taking a cubic root, and then adding 2 to all of that, and claiming that this is your inverse. No restriction on the domain, luckily, because the domain is going to be all real numbers. Cubic roots give us that power to take the cubic root of a positive or a negative number. Okay. Yeah, what else? Suppose you have a polynomial function of degree n where n is an even integer. Which of the following statements is always true? F is even. Well, let's imagine if it's a polynomial function of degree n, I'm going to say sometimes, because, allow me to entertain this, if you have x squared plus 1, just vertical shifts, those will work. That's a polynomial function. That's degree n, it's even. However, if you were to have a horizontal shift, like x minus 1 being squared, this is going to be still a polynomial function of degree n, where n is an even integer, lo and behold. And this actually is not even, because this has a horizontal shift. Vertical shift's okay. Horizontal shift's no good. Peace. I'm going to leave B and C for you. If d for f of x approaching infinity and x approaching infinity, I hate it when they rewrite these. But so as x is going towards the right, f of x goes to infinity like that. Okay, I can buy into that. And then as x approaches negative infinity, f of x approaches infinity. Okay, so it's saying that that is it. Well, even exponents don't always open up. So I'm going to say sometimes true. Because, for example, if you get positive x squared, yeah, it looks like that. But if you get negative x squared, that flips the end behavior. And those are conflicting. Those are not the same thing. Makes sense? I think that's it. Wow. Oh, a lot of problems. Hopefully you enjoyed this ride with me. I see that I'm still recording, so I don't have to go back and do this, luckily. I hope you have a great day. Best of luck studying. Reach out if I can help with anything. Take care, brush your hair, and relax. You got this.